Okay, let's see how would we approach the question. That is basically the only thing, you know, there's so many ways of asking circles. So the big secret is not to panic. M is the center of the circle. Okay, if I see center of the circle, I know what? I know radii. Immediately I know that one and this one and that one is going to be equal in distance. If I see diameter, immediately my brain goes into angle, semicircle. You see, so that's immediately what I will think of. There I sit with a semicircle. And, okay, I also sit there with adjacent angles on a straight line. Welcome to Flisu. So M is the center of the circle and I have a diameter. Then it says ME is drawn perpendicular to AC. Okay, ME is drawn perpendicular to AC. Okay, that was given such that CDE is a tangent. CDE is a tangent to the circle at D. Okay, clearly, so I said, if you do see circles, don't panic. Start by literally just filling in everything from your questions before you look at the actual question. If I hear the word tangent, two things that I'm thinking of. The tangent always has two options. The one is tan chord, meaning if there's an angle between the tangent and the chord, a chord is any line that's not a diameter, this angle will be equal not to this line, but it will be equal to the one in the opposite quadrant, you know, there, or not quadrant, segment. What is the other one? Other option, if you hear the word tan, is when it's going to be the radius that's actually perpendicular to the tangent. If you do have a radius, it's going to be perpendicular to the tangent. So this is one thing here that we must remember. I sit with a tangent and I sit with a radius. Can you see? This is going to be an option. This is going to be 90 degrees. And another thing, I can say my x, because that forms a triangle. And you see BDA forms a triangle. So D4, we can say will be equal to angle A. Right. Okay, I'm not waiting for answers because, you know, we just want to do as much as possible. So I'm just showing you that's how my November revision works. I just show you how I would approach questions. If I sit with D1, D1 we can say will be equal to B2. Right, but also ask questions, right? Please, please, please feel free. It says here, if D4 is equal to X, write down with a reason two other angles that will also be equal to X. Okay, I saw one, so I'm just going to say D4 is equal to angle A. And that's equal to X. Tan chord. And we always fill it in on the drawing. Right, can we see another one? Yeah. D2. Okay, Taskeen is saying D2. Yep. Angles opposite equal sides. Well done. Can you see it's now sort of easier to see that angle A will be equal to angle D2 if you did what I did, if you just, if you drew, oh, it's very small, let's go bigger. If you drew those sides that are equal, you see, then it's so sort of easier to see. Well, if you didn't draw it, then it's not that easy to see. Yeah, so we can say angle A is equal to angle D2 equal to X. Angles opposite equal sides. Sharp. While I'm looking at this, can you see that M1 will actually be equal to 2x's? It's one of those ones, angle center circle is equal to twice the angle on the circumference. I don't know if you can all see it or remember this tricky one. It's not really tricky, but it's sometimes not so easy to see. All right. So if this is the center of the circle, although it's a straight line, we are used to it not being a straight line. This is what we are used to. Right. This is what we are used to. Where if that is a x, this one will be a 2x. So with this one, even if it's a straight line, it's fine. Where that is a x, this one is going to be 2x's, angle center circle. Let's see what else. So I'm just going to fill in what we just got. And remember now that one will be equal to 2x's. I'm just putting it in for whatever. Okay, we must prove that CM is a tangent. Prove that CM is a tangent. So if I see questions like that, I first will ask myself, when will it be a tangent? Meaning, I'm going to see what must I try and prove. When will it be a tangent? Prove that CM is a tangent at M to the circle passing through M, E, and D. M, E, and D. Now, I've had it in the past where pupils will sometimes treat this as if it's now a circle. Okay, M, E, and D. So this is now going to be the invisible circle. And I must try and prove that this is a tangent. At M, CM is a tangent. So what do I have there? If I look at M, I'm just redrawing it just so that you can see it better. And if you can't see it, you can quickly just redraw it at a terrible speed in the exam, okay? When will MC be a tangent? It will be a tangent if I can prove that this one is maybe equal to this one, right? Then it's going to be a tangent. Or if this one, if I can prove that this one is equal to that one. You see, if M3, if I can maybe prove that M3 is equal, so I'm looking at this triangle, MED. I can prove it's equal to not to this line, but actually equal, to the opposite angle. So that's tan chord, if I can prove any of those. Right, let's see if we can prove it. seems is it going to be possible to prove that E is equal to 2x's? Because I know M1 is going to be 2x's, right? Is this going to be easy? It doesn't look too easy to me at all. The one that I'm seeing, okay, I'm just checking what they did because there's one that I see. Okay, what I'm seeing here, that one is 90 degrees, M3. And what about this angle here? This is a tangent. Didn't they say this one is a tangent? Yeah, CD is a tangent as well. So what do we know about this one? This is 90 degrees, is it not? So I can say that's one option. They made use of another option. M3 we can say is 90 degrees. Why? It's given. But D1 and 2, this D1 and 2, this one, is also 90 degrees. You see, that one is 90 degrees, but this one is also 90 degrees because it's tan radius. This is a tangent, and that's a radius. Angle D1 and 2, angle D1 plus 2 is also 90 degrees. Radius perpendicular to tangent. Then, therefore, CM is a tangent. What you can do here, you can just write converse, meaning the opposite. Converse of tan, angle between tan and chord. It's the opposite. Because it forms an angle between a tangent and a chord, therefore it will be a tangent. I will maybe just say here, therefore angle M3 is equal to angle D1 plus 2. On the memo, let me show you what they did on the memo. On the memo, they worked with the M1, which is equal to 2x because it's angle center chord. Just want to see what they did. So they worked with that one, which is 2x. So it means it's here. That one is 2x. Then they said MDE is 90 degrees. MDE, okay, this one is 90 degrees. Radius tan, MDE is 90 degrees. Okay, the reason that we also worked with. Therefore, M2. Okay, then they decided to work with adjacent angles in a straight line. Well, if you don't say converse, then it doesn't make sense to me because we can't say, so I would say yes. Taskin, make use of the word converse. Because we didn't make use of tan chord. You see, tan chord will be if they give you the tangent. You see, but this is not what happened here. This was proving it's a tangent. But yeah, Taskin, they will mark it right if you didn't use the word converse. But converse just means it's the opposite of your tan chord. All right, I would use it because, I mean, it's more correct. But they won't really mark you wrong. Okay, where are we now? So this one is 90 degrees. And then what they did here, they just worked out M2, with adjacent angles on a straight line. So this one will work out to be 90 degrees minus 2x. And then to figure out angle E, they worked with interior angles of a triangle. So they said angle E plus that 90 degrees minus 2x plus angle D1 plus 2, right? Interior angles of a triangle is equal to 180. And from that, they just got that angle E is 2x. right? And then therefore, yeah, in the memo, they also worked with the opposite of tan chord. You can use the word opposite. Converse just is the mathematically correct word. Therefore, E is equal to 2x, and therefore CM is a tangent. Right, because of the opposite. Then they say prove that FMBD is a cyclic quad. Okay, so now we must just fill in everything that we do have. This was the X. So while I fill in everything, okay. Firstly, when is something a cyclic quad? If I can maybe prove that that angle plus this one adds up to 180 degrees, if I can somehow prove this. And a tip from me, very often, if you see a 90-degree in your diagram, it means very often you are going to work with this, right? Opposite angles are supplementary. Your bow tie. If you see two angles that are equal, you can say angles in same circle segment, if I can prove that. Third one, if I can prove exterior angle is equal to the opposite interior angle. Right, let's see, where is FMBD? Okay, FMBD, okay, I can prove that one. FMBD. Right. And remember this one, radii, so that one and that one's equal as well, right? That side and that side is equal. So we also know that D3 is also going to be equal to B2. Okay, the easiest one that I'm seeing here. Does someone see it immediately? All right. Well, let's put it like this. Let's first look at angles in same circle segment. To prove that this red shape is a cyclic quad, is it possible to have a bow tie here? You can just see it. It's not possible to work with a bow tie there. Is it possible to prove that the opposite angles are equal to 180? Meaning, is it possible to work with these two to say that it's 90 degrees? Yeah, it is 90 because M3 is 90. Can I possibly say that D2 and D3 is 90 degrees? Because if I can do that, I can actually then also work with this one. Then I can actually say M3 is equal to M2 plus 3, which is 90. So I can work with exterior angle, and I can work with opposite angles are supplementary. But then it means I must try and prove that D2 and D3 is 90 degrees. Look at the big picture. Is it 90 degrees? Yes, indeed. Angle, semicircle. You see that one? There. You see, this forms an angle in a semicircle. So that D2 plus D3 is indeed going to be 90 degrees. Okay, so that solves the whole problem. So it's your choice. I'm just going to say M3 is 90 degrees. Why? It was given. Then I'm going to say D2 plus D3 is 90 degrees. Angle, semicircle. If there's anything that you can't see, please, you're welcome to ask. That's 90 degrees, angle, semicircle. Therefore, FMBD is a cyclic quad. Exterior angle equal to the opposite interior. Right? Or you could have said that is equal to, you could have said M, let me just put it in here. You could also have said M1 plus M2 equal to 90 degrees, adjacent angles on a straight line. You see, and then just work with the same way. Okay, now if there's no questions, we continue. Look at this one. This one. While you're looking, I'm just filling in. Right, what now? If I see something like DC squared, there's two things when I see these type of questions. The first thing that I do think of normally, that's what I always think of, is trying to work with similarity. That's one option. You know, the normal DC times DC. Okay, that's now 5 BCs, which won't be possible. But let's say you had a AC and a PD or whatever. Then we can always just cross multiply, you know, where you say that one on top of that one is equal to the DC at the bottom and the PD. So if you do see a question like this, you expand it, you take it back into fraction format. And can you see here, if you cross multiply, and you can say DC squared will be equal to that one times that one. So you just make sure the one is at the top and the other one is at the bottom. And you try to find two triangles then. And try and prove that two angles are equal, working with similarity. Right? But is this going to help me to get to this question? So what is the other option? If you see a square, Pythagoras. Why? Because I have a 90 degree. So let's see where's DC squared. Okay, so DC squared is there. So I can actually work in this triangle. Please take note, you can't see the answers. The answers very often, you only see it when you first just randomly, desperately try something. So I tried to look at similarity and I realized, it's not going to work because even if I can't form triangles working with DC. then it means I'm going to try Pythagoras. I'm randomly going to say something about DC, because, so I can say DC squared will be equal to MC squared minus MD squared. Then let's see. Okay, so I've got the DC squared, so halfway there. I need to say something about BC. It means I must substitute all of these with a BC. Okay, so it means get rid of the MC. Okay, let's see. What else did they say in... Or let's see, what can we do here? Okay, this one. Let's quickly see if there was something else in the question. Yeah, you see, I didn't go back to the question now, so I was nearly stuck. ME and chord AD intersect at F, all right? But then, look here, MB, this one, is 2 times the length of BC. Okay, you see, I should have copied the question. So that's part of the question where it actually says that MB is equal to 2 times BC. MB is equal to 2 of those. So if MB is equal to 2 of the BCs, it means AM will also be equal to 2 BCs, you see? So this is just 1 BC. You see what I'm doing? This is 1 BC, and this is going to be 2 BCs, and this will be 2 BCs. So what can I do? How can I write MC? So MC is going to be how many BCs? Because I only want BCs in my answer. Well, I'm first just going to say MC will be equal to 1, 2, 3 of the BCs. And what will MD be equal to? Well, MD, can you see, is equal to MB. But MB is equal to 2 BCs. So I can just sub this one in with 2 BCs. You see how you would approach it. And my answer must be in terms of BCs only. So can you see that you couldn't see the answer, but you randomly started off with Pythagoras? And of course, this was a tip or a hint. So then you just literally do what I did. You go to the drawing and you fill it in like that, and then it becomes clearer. So this then I can write as 9 BC squares minus 4 BC squares. That's going to give me 5 BC squares. Sharp. That's a little bit tricky, I know. It also asks us now to prove that triangle DBC is similar to triangle DFM. Right, so to work with similarity, we just need to figure out 3 angles. Okay, so again, we need to just quickly fill in the X's there. Now try and look for the triangles first. I think I've got everything here. Right. Okay. Triangle DBC. Let's see, where is it? DBC. Okay, there's triangle DBC. What I often do is, can you see DBC? Can you see this angle D is a X? So I like to do it like that. I already have DBC and I already have that one as a X. DFM, DFM, DFM. That one was 90 degrees minus X. Okay, so it's not that simple. So let's see. Okay, maybe what I will do, I will quickly just DBC is that one. Okay, and my other one is DFM. DFM. It's just for teaching purposes, or if you do struggle to find it, you can also just quickly draw it, DFM. Okay, D4, this one, is equal okay, this D4 is equal to angle A, right? This one is equal to angle A. So, okay, let's start off. In triangle DBC and triangle DFM. This D4, we said right in the first question, we said D4 is equal to angle A. And we also said angle A. You don't have to prove this again. I'm just saying angle A we said was equal to angle D2, right? So basically, you don't even have to write this. You can just say D4 is equal to D2 is equal to X, proven. Yeah. Angle A is equal to angle D2. And we also said here that D4 is equal to D2. See, because they were both equal to X. So you can just say proven. Sharp. So we've got one angle. One is sorted. Okay, we need another one. Okay, so go and look at your triangles. Here's the one triangle. And don't ever forget what we just proved. In one of the previous questions, we proved that this is a cyclic quad. Okay, and we are now working in this triangle, and we are working in this triangle. So very often you will be working with the stuff that you just worked out previously. So what can we see here? B1. Can you see, if I can say something maybe about B1, I can't really say something about C because we haven't worked with C. But B1, we can say will be equal to F2. Can you see it's the exterior angle of this cyclic quad? Because we proved that this was a cyclic quad. You see, so now it's going to form an exterior angle is equal to the opposite interior angle. And then we are sorted. So as long as you don't panic, Mohammed said, I must please to circles. He's panicking about circles. Don't panic. You literally just make drawings and you see and you ask yourself and you try and see what you worked with and if you can't use it in the next one. And you know what? Let's say you couldn't do this one. You will get marks for all the others. It's very often just 1 or 2 marks that you will lose. So I can say that B1, okay, so here I've got my first angle, and now this is my second angle. B1 is equal to angle F2. It's this B1 is equal to angle F2. Exterior angle is equal to the opposite interior angle. And third one is just going to be angle C, therefore angle C will be equal to angle M2. So therefore this one will be equal to that one. Why? Because of interior angles of a triangle. And then you just end off saying, therefore, triangle DBC will be similar to triangle DFM. Angle, angle, angle. Right. Not so easy always. Okay, then it says find the value of DM on top of FM. Of DM, this one, on top of FM. FM, oh, okay, panicky. Right, again, what did I say previously? That we work with stuff that we just worked with. So we just worked with similarity. So let's see if we can't make use of the similarity. And the only values that we so far had was that was BC, and this one was 2 times BC, and this was 2BC, and this one was also a 2BC, remember, because it's radii. Right, so let's work with what we just worked with. You know, we just proved that triangle DBC was similar to triangle DFM. Right, that's what we just did. Is there maybe a DM? It looks like it. Is there FM? Yep, there is. Right. So I can say DB on top of DF, that one on top of that one will be equal to BC on top of FM. That will be equal to DC on top of DM. Similar triangles. You can either write here similar triangles, or you can just say that triangle DBC is similar to triangle DFM. Okay, any of the two. Now let's look for our DM. Okay, there's my DM that I need, and FM is there. Okay, so it means I want to work with these two triangles. So I want to work with BC over FM, and I want to work with DC over DM. Okay, I must get DM on top of FM, but they're down here. No problem. You quickly cross multiply. Right. So again, I just want you to see how you would approach the questions. You literally look at, okay, where are they? How can I get there? And then you just sort of, you know, look at your similar triangles. You see you need that. Okay, but they're at the bottom. So let's try and cross multiply. I want the DM at the top. And I want the FM at the bottom, so I'm going to divide this side with FM. Then I sit with DC left over there and the BC left over there. So you just do that. And you sub in what you just worked out previously. DC, D, sorry, DC, we just worked out. What was DC? We worked it out. We worked out that DC squared was equal to 5 BC squared. DC squared was equal to 5 BC squared. So therefore, I can sub DC with what? Square root of 5, and you just get the square root of BC squared. So DC squared we can write as square root of 5 BC. And we already have BC. Voila, square root of 5. Got it. Seems I copied you another slide. Let's see how many slides do we have. Okay, it's only 2 there. If we can quickly do this. In this diagram, O is the center of the circle, right? So if O is the center of the circle, I'm going to fill in radii. Also, if it's in the center of the circle, I see a 90 degree. Then it says if the midpoint of the chord, okay, the midpoint of the chord. So if I see this picture, it's from the center of the circle. What jumps into my brain here? Center of the circle, and it's cutting a chord. Ah, theorem 1. You see this one, line, center circle, bisects chord. So what does that mean? It means angle F, and F1 is going to be 90 degrees. And that's actually the first question. Give a reason why oh no, it's not that one. Why is DAB equal to 90 degrees? Angle semicircle. Okay, question 2, they say, give a reason why AGOB. Okay, let's see, where's AGOB? AGOB. Right, now you can see angle O is 90 degrees, it's given. And angle A1 and 2 is 90 degrees because it's angle semicircle. And voila, that's why it's going to be a cyclic quad. You see how they always guide us? I can just say angle A1 plus 2 is equal to 90 degrees. You can either just say proven or angle semicircle. Angle O is 90 degrees, that's given. Therefore, AGOB is a cyclic quad. Opposite angles are supplementary. Right? Okay, next one. Prove that AC is parallel to GO. Right, so prove that. So the first question you ask yourself is when will it be parallel? When will AC be parallel to GO? If I can prove that this one is a 90 degree. If I can prove F1 is 90 degrees, I can say, okay, they form, you see Taskeen, then again it's going to be converse. or just opposite. So if I can prove F1 is equal to O, then I can say, therefore, GO will be parallel to AC, because it's the opposite of proving, that it's actually equal because it's parallel lines. Right. So I'm just going to say angle O is 90 degrees. And F1 is 90 degrees. Why? F1 is 90 degrees, line, center circle bisects the chord. Right, then it means it's 90 degrees. And therefore, AC will be parallel to GO. Converse, you know what? You can just say here corresponding angles. It forms corresponding angles. Okay, then G1 we must prove is equal to B1. G1 and B1. 4 marks. Okay, G1 and B1. Okay, we know this is let's quickly see if we can somehow prove it. Just remember this was the cyclic quad. All right. This one is equal to that one. I know this one will be equal to that one there. B1 and G1. B1 and G1. Okay, that's 90 degrees. Angle. Okay, I'm thinking of congruency here. Please remember we will be, they often work with congruency. I can say this one and this one will be equal and the sides will be equal, but I can't prove that one is equal to that one. Okay, G1. Let's see if we can't say anything about G1. Right, so if we are stuck. Oh, and what else? Okay, I see it now. What else? We just proved, again, I was a little bit stuck. And then I remembered, okay, what did we just prove in the previous question? In the previous question, we had to prove that these two lines are parallel. And I made the classic mistake of not filling in everything on my slide. Okay, I didn't fill it in. So if these two lines are parallel, what can I say about G1? Well, G1 is equal to A2. You see, angle G1. So you see, it's not that difficult. Just always write down everything on your slide. G1 is equal to angle A2. Why? Corresponding angles. Because AC is parallel to GO. Okay, so G1 is equal to A2, but I must try and get to B1. Can you see B1 forms? If you put your fingers here, angles in the same circle segment. Can you see it? You put your finger on C and D, and you go to A and you go to B. So I can also say that A2, I like to write the same angles underneath each other. A2 is equal to B1, angles same circle segment. Therefore, G1 is equal to angle B1. All right.